All right, guys, we're going to do a little bit of chemistry review here. So we're going to talk about the atom. Yes, your friend and mine, the atom. Okay, because we need to understand how the atom works, functions, if we are going to go into electrostatics, because it's based more on your knowledge of the atom than your current knowledge of physics. So, yay, chemistry was real. So let's do this. All right. So let's pick a solid color here. All right. Let's go with a different thickness. Works for me. All right. Sweet. So let's talk about the atom. If we look at the atom, inside the nucleus, we have protons and we have neutrons, and they're living inside the nucleus. And then the thing that surrounds them, moving very fast, are electrons orbiting that nucleus. All right. So protons on the inside, neutrons on the inside, electrons on the outside. As you can see by the sign, and as you probably remember, electrons have a negative charge, protons have a positive charge, and neutrons are, yes, neutral. Oh, sweet. Okay, you remember all your chemistry. Very excited. I'll tell your chem teachers. All right. So this is our fundamental understanding of the atom. Okay. Now, why do we care? Well, when it comes to electrostatics, it's all about the electron. So we need to understand how things work because we're going to be working with real life scenarios, real life objects. Okay, so let's talk about bonding. Okay, so I'm sure you remember from chemistry all the different types of bonding. We have covalent bonding. All right, covalent bonding. We have ionic bonding. And we have metallic bonding. So now, if you remember in covalent bonding, we have electrons that are being shared. All right. So you'd have, oxygen is a diatomic atom, so therefore it's always O2, okay, because it has to share some electrons for things to work out. So a lot of organic materials share electrons, and so they have covalent bonding. So those electrons, since they're being shared, are not exactly free roaming electrons. Okay, they're kind of tied down where they are. Ionic bonding, you know that you are, I guess, trading electrons, right? We'll go with trading. I'm sure a chem teacher's yelling at me right now. All right, you're trading electrons. You're going to be saying, "Oh, I've got too many electrons. I have that unfilled valence shell, and you'd love to have an electron, so we're going to work together. So one's going to gain an electron, one's going to lose an electron. So, but either way, once that bond is formed, that they're kind of locked in place. Now, metallic bonding, that's where things get interesting, and this one has a sea of electrons. So what this means is that when you have metals bonding, all right, then the electrons are kind of allowed to flow. They can move around very easily. So these two, we have limited movement of electrons, and here we have free roaming electrons. Okay, so here for covalent ionic bonding, the electrons they can move a little, but they're kind of there. I often think of them as, you're being married, you're kind of tied down, and you've made your choices. They're good choices, by the way, and you're happy with those choices, but you're not still roaming around looking for options. Whereas in metallic bonding, they're still roaming around looking for options in life. Okay, so that's the big thing here because when it comes to electrons being able to move, covalent and ionic, they can't move that much, but metallic, you can have a lot of movement. Now, why is this important? Well, this is important because in order for electrostatics to be a thing, you need to be able to gain or lose charge. So if you gain or lose charge, what that means is you have an excess or what's the opposite of excess? Lack of? Depletion? I don't know. Or I'll just write lack of. All right, you've got either you have an excess of electrons, so that means you've got a negative charge, you have too many electrons, Or if you have a lack of electrons, I guess I'll use that line that's already there, you have a positive charge. Okay? Now, in either case, and I can't stress this enough, the only thing that can move are electrons. Okay, so when you have two objects and one gets a positive charge, one gets a negative charge because they've gained or lost electrons, well, it's not because they gained or lost protons. Okay, one of the ways that we are most familiar with charge happening is often in the winter, where you'll get out of bed and all of a sudden you'll touch the doorknob and you'll feel that shock. Okay, that shock happened because you rubbed up against something, and certain things like to be more positive, certain things like to be more negative, and so you either gained electrons or you lost electrons. Okay, so that's how you get those charges. If you were to move protons, all right, so if protons were allowed to move, then life would be weird, okay? If protons were allowed to move, then that means instead of waking up in the morning and getting an electric shock, you'd wake up in the morning and your hand would be uh, a different material. Okay, you're like, oh man, I felt that shock, so my protons changed because proton defines what the element is. So your hand, instead of being made up of organic molecules, carbon and oxygen, all those fun things, be like, oh my god, my hand is lead. Awkward. You know, don't get shocked. You'll change what you are. So so yeah, that's kind of a thing. So if protons were allowed to move, then the the uh, the object would be different elements. All right, so instead of just having a shock and some electrons move around, you'd have them physically changing into different elements, and that's kind of awkward. Okay, life would be totally different if that was true. Okay, so the only thing that can move are electrons. And if it is metallic, then the electrons are allowed to move very freely. So that's why we call these things, let's bust out a different color here for fun. So metallic here, these are our conductors because electrons are allowed to move freely. These here are our insulators because the electrons cannot move freely. And it's kind of like this spectrum, okay? So on one side of the spectrum, we've got covalent because they are shared the tightest, and then ionic, you're more likely, you're kind of in between, and then metallic, you're definitely a conductor. Now, there's always outliers to all these scenarios because it's chemistry, and chemistry does not have super hard and fast rules to everything. They've got like 99% rules instead because there's always like the oddball. But that's kind of the hard and fast rule. Okay? And so that's just some of the basic stuff you really need to understand before we start electrostatics, especially this idea that the only thing that's going to be running around are electrons. And if you get an excess of electrons, it has a negative charge. If you have a lack of electrons, you have a positive charge because you have more of a ratio of protons to electrons. Okay? So again, just the basics of the atom. So that when you start doing our discussions on electrostatics, you remember all that stuff and you're going to be on better footing. Well, I hope that was great, and I hope you guys are doing great. And it's literally in the morning for me, but I think we made it through this. So nice job, guys. Until next time, I'm your host.